So we're going to talk about the union and intersection of events. So they've given you this symbol, which is set A in the union was set B. Okay, so this is our union. Is known as, when you write it as a sentence, of set A or set B. And I'll draw an example of that. And then the other one we have is A in the intersection of set B is known as when events A and B are occurring or intersecting. So what does that mean when we're doing maybe Venn diagrams? So the union of two events. First what we'll do is we'll just say all events exist in this one area here. We'll make a bit of a box. Okay. And we'll do an intersection of the events too. So for the union of events, these are when we have disjointed. So actually we'll make both of these unions. Okay, and I'll show you. One is disjointed and one is, so in other words, mutually exclusive, and the other one's not mutually exclusive. So these are both unions we're going to solve. Okay, and we're going to call this event A and this event B, which means this is event A and this is also the event B. These are in your book known as mutually exclusive, or sometimes disjointed. And these are non-mutually exclusive. So in other words, these events can occur at the same time. So we'll talk about, and I guess you would just say non-disjointed or jointed events, you could say. I'm not sure how your book will refer to that. So we'll talk about this. And then they're all within a set. So let's say we're talking about old school traffic lights, maybe, would be a good example. And we'll call this set C. So C is the box. So when they're talking about sets here, C is everything. So all the events occurring. Set A, we'll say, is getting a... Okay, so in your book they've used a red light. So we'll call this a red light. Okay? I should use red. So you get a red light when you pull up to a light. And event B is getting a green light. All right? The reason these will be disjointed events is because you can't pull up to a light and get a red and green light. Okay? Mm-hmm. I know they sometimes call that a yellow, right? But let's just say we're talking about old school traffic lights. You only have red and green. Okay. So when I pull up to her, I only have the option of getting a red light or getting a green light. Now, technically, they're not identical. Like you wouldn't, they wouldn't occur all things. And you could say we're leaving out the yellows. Yeah, okay, we'll keep it at that for now. So let's say you have a probability of, oh yeah, and this makes sense, pulling up to a light. You have a 45%, or known as 0.45 in terms of probability, chance of getting a red light. And then I'm just making these numbers up, okay? Let's say you have a 48% chance, or a 0.48 chance of getting a green light, okay? Now I know in terms of size this isn't great. These circles should have been way bigger in compared to this box. But probability needs to add up to a 100%, right? In terms of being a probable event. Well, 0.45, let's talk about the addition rule. So the probability of the union of A and B. So let's talk about how we could write these. So the probability of A and union B, okay, is equal to, when they're disjointed, it's just equal to the probability of A plus the probability of B. So what does that mean for us? Well, the probability of A was 0.45, right? So getting a red light, we had a 0.45 chance of getting a red light. And the probability of B, getting a green light, was 0.48, so 0.48. So what's the probability of you getting an A? And remember we said this kind of says A or B. Well, when you pull up to a light, you have the chance of the probability of getting, what is that when you add that? 0.93, or known as a 93% chance you get either a red or a green light. Okay? Well then, what's that other 3%? Okay? And assuming there's no yellow lights, maybe the light's out, right? Oh, never pulled up to a light that doesn't have red or green. It's not working. Electricity's not working. So that would be like event C, right? The light being out. That would be the idea there. Now, technically, the light can't be out in with the red and green, so this box shouldn't encompass it. But I'm just giving you a different idea there. Why doesn't this add up to 100? Well, because there's the possibility that the lights are out. Okay, so that would be something that's separate. Okay, now in the non-mutually exclusive events or jointed events, let's talk about red, yellow, and green lights. Okay, so say we have a red light again, a green light again, and what we're going to call is this part here, we're going to call those yellow lights. Okay, so in other words, we just assume a yellow light is when it's both red and green, we'll say, even though we know the colors don't mean that idea. Well, the probability of that union is a little different, okay? Because when they're looking at probability of the union of A and B here, they're talking about A or B. Well, A or B does not include, and I'm going to highlight the part it doesn't include. It does not include this area because that's A and B.
Okay.
So to find the probability for that guy, you take the probability of event A plus the probability of event B, subtract the probability of event A and B. Oh, sorry, that U should be upside down. That looks confusing. It should be like this, A and B. Okay, and I'll kind of zoom out here. Remember, the upside down meant the intersection, and this is where the two events intersect.
Okay.
So in this question, this light actually has yellow lights, let's say. Okay, so because it has yellow lights, in this case, what's the probability of getting A or B? Well, that's getting a red light or a green light, which means we don't want to know when you get a yellow light. So a yellow light will actually have to subtract that amount. So let's say maybe, and we'll do the math for it too in this one. We'll say a yellow light includes being red and includes being green. Okay, we'll say that's the union. Though I know in real life that doesn't seem like it is. Let's zoom in and let's give it a probability. So let's say that the probability of getting a yellow light is 0.02. Okay, while the red light probability stayed the same, 0.45, and the green light probability stayed the same, 0.48. Okay, well, in order to calculate this, the union of the two events, we have to use this formula here because this is non-mutually exclusive. This is where the events occur with each other. So in order to calculate this, okay, scroll down just a little. The probability of the union of the two events is equal to probability of A, which is our 45, 0.45, plus the probability of 0.48, but because they want it red or green, they don't want yellow lights, we have to subtract the union of the two.
Okay.
So 0.02. So in this case, I think it becomes 0.91 in this case because we've taken out that yellow. Okay, we've taken this yellow out of it. Before it was 0.93. This one is 0.91 because we've taken out the option of getting a yellow light. So you have an almost 91% chance of getting a red or green light when they're mutually exclusive, so when they're joint events. So that changes things, whether something is disjointed or jointed. In other words, mutually exclusive or non-mutually exclusive.
Okay.
That changes how we do that. And that's with just the union. The intersection of something, the intersection doesn't exist in this one.
Mm-hmm.
Okay? Because in this one, our diagrams don't cross each other. They're just jointed events, right? So there is no intersection of A and B. But if they asked us for the probability of A and B, well, that's talking about when we get a yellow light. And in that case, that would be 2%. Okay? So that's when they're talking about the intersection of things happening. Okay? And is there any other things? Okay, so now let's say with this one here, because this one is a little harder to calculate, because red was included in yellow and green was included in yellow, what if they asked us, and this will be the last part, what if they asked us the probability of just A. Okay? Probability of A not including this part here, yellow. I'm trying to remember how they denote this. We want probability of just A happening, so only getting a red light. So what's the probability of only getting a red light? Well, that doesn't include the yellow. So in other words, when I go through the highlighting,
so I have to subtract both?
yeah, so what we're going to have to do here, so we're going to have to do a little bit of subtraction again. Because remember, we had a red light. We knew it was 0.45, right? It was 0.45 to get a red light, but there's a 0.2 chance of getting a yellow light. So actually, to only get a red light, to pull up to a red light only, we got to take that event, which is the probability of A, and we got to subtract the union of the two, the probability of A, not the union, sorry, the intersection, A and B. Well, for a red light, that was 0.45. Subtract the 0.02, which means to only get a red light, you have actually a 43% chance. So for this guy here, for just A, not including that, that's 0.43. Okay. Now let's think about green light. I used some funny highlighting colors here. Now that I look back, I should use green for this. But here's the same idea. What if they said only getting a green light in this one? Well, that's the same idea. We'll have to take the 0.48, right? And we'll have to subtract that 0.2. So probably, now this isn't written in right set notation. Okay. Let's say getting green light. I got to look that up again. Green light, and I'm going to change the other one. This shouldn't be written like this, because that's not the probability of A. Let's just say it's red light. Just getting a red light in this case. Well, just getting a green light, we're going to take the probability of event B, and we're going to subtract the intersection of the two, A and B. Well, for a green light, it was 0.48, but there was also a 2% chance you got a yellow light. So we take the 0.48 and we subtract that 2% chance, and it turns out you have a 46% chance of getting just a green light when you pull up. Okay. And again, remember, we were using yellow as like the joint there, that idea. Yeah. But that's the difference between union and intersection of events.